Hi, my name is Tim Middleton. Welcome to the second screencast in this series where we talk about a new feature in Coherence called persistence. In this screencast we're going to go into more detail with some advanced topics. Firstly, we'll go through a persistence recap, and if you haven't seen the first screencast, please refer to that for more detail. Then we'll have a look at a tooling overview. We'll look at archiving and retrieving snapshots, and then a demonstration. In 12.2.1, the new persistence feature provides durable storage of your cache data and associated metadata. This means that data will not be lost on scheduled or unexpected shutdown of a Coherence cluster. On Coherence cluster startup, the persistent data is automatically recovered and the caches are populated with the data and metadata present at the time of shutdown. In previous versions, you would have had to manually warm the caches from the database or other location. Persistence also provides the ability to create a point-in-time snapshot of caches for backup or transfer from production or QA environments. These snapshots can be archived to a central location or recovered using various tools to revert caches or services to a known state. As well as cache data, various metadata is also persisted, including indexes, locks, listeners, and triggers. A number of storage topologies are also available, including local storage and shared storage, depending upon user requirements. The following set of tools are available to allow users to interact with the persistence features in 12.2.1. Using a standard JMX connection from any tool above, the persistence coordinator mbean primitive operations, which I'll explain on the next screen, can be issued against services. The Coherence JVisualVM plugin provides capabilities in the new Persistence tab for easily executing operations and monitoring persistence-related mbeans. CoQL, or the Coherence query language, provides commands for issuing all the snapshot operations and can be scripted for ease of use or batch operations. There's also support for issuing commands via WST when using Coherence in a managed environment such as WebLogic Server. The storage senior for a partition service or federated service will register the following mbean to allow for persistence operations to be executed. So the type is persistence and the service is part of the key and the responsibility is a persistence coordinator. Once this is registered, the following operations are available on this mbean. Here we have a screenshot using JVisualVM we have connected to the mbean server, and we can see we're under the persistence node. The service called partition POF cache, we've selected the persistence coordinator. And we can see the operations that can be executed. As mentioned, we can also use the JVisualVM plugin, which provides a right-click option on the Persistence tab to issue the operations. CoQL is a tool to interact with Coherence clusters, and we've added additional functionality to interact with the Coherence persistence feature. So, for example, we can create snapshot, recover snapshots, validate snapshots to make sure they're recoverable, and so on. I'll go through these in a bit more detail during the demonstration. WST can also be used to issue persistence commands. You must be in the domain runtime mbean tree for these commands to succeed. Any errors will raise a persistence exception in WST. And as below you can see, we have the following commands available. Snapshots can be created on local disk and as such can be distributed across many servers. They can be archived to a central location as a complete snapshot of a service for historical or archiving purposes. Validation can be performed to ensure the archived data is valid and recoverable. Snapshots can also be retrieved from the central location for local recovery. Now we'll have a demonstration where I'll issue some archive and retrieval snapshot commands. I'll then use CoQL to issue persistence commands, and then we'll look at operations within a WebLogic server environment. Firstly, what we're going to do is start up a couple of cache servers using the -JMX option, which allows us to interact with the mbean server and run the operations. So I'll start them, and then I'll run the query.shell, which is the out-of-the-box script for running CoQL. So within CoQL, I can issue the command, and that gives us a list of commands that are available, and we can see we've got new commands here, which allow us to interact with the persistence features. So if I then say use list services first, we can see we've got one service called partitioned cache service. So I'm going to create a cache called Tim, and insert into Tim key 1 value 1. Select star from Tim. So what I'm going to do now is create a snapshot with this in. So create snapshot Tim and partitioned cache. Now we can see here that we've got some validation. So I misspelt that, and so I can go and reissue that operation. And you notice when you're running interactively, it asks you for confirmation when doing create, recover, and retrieve snapshots. When you're running in batch mode, it will automatically answer yes to those. Alright, I need to get my spelling, so how about I copy and paste that. Third time lucky. There we go. So service partition case has been automatically suspended and resumed. So if I then say list snapshots, partition cache, we've got one snapshot called Tim. I'm running this demonstration on a single machine, but imagine you're running this across multiple physical machines. Then the snapshot I just created would actually exist on multiple machines on each of the members that own the data. So what I can do now is I can archive the snapshot to a central location, which would mean that we've got a complete set. Before I do that, let's have a look at how the archiver is defined. So if I look at the override file, I've defined a snapshot archiver, and this is a directory archiver, and the archive location is here. So what that means is typically that's a shared directory. This is a local directory, but typically it's a shared directory amongst all machines. So it's by cluster name and service name. So at the moment we can see there's no archive snapshots here. So if I then said archive snapshot Tim for partitioned cache. I want to confirm that. So what it's doing is it's now archiving that. So imagine it's over separate physical machines. All those machines will issue those operations in parallel, so it's very efficient. If I then said list archived snapshots, we can see now an archive snapshot called Tim. If we now go to the physical directory, we can see there's a directory called Tim, and if you look in there, there's the data there. So you don't have to worry about the format of the data, but basically it's in a binary format which can be recovered. So once I've archived that, before I say remove the local snapshot, I want to validate that. So I can say validate archive snapshot, and you can actually validate a local snapshot as well. And I can specify a verbose option. And what that verbose option does is actually displays detailed information about the contents of the archive snapshot. And while this is doing it, it's actually bringing the snapshot partitions back and ensuring it could be recovered. And the verbose option then gives us the information. So it says how many partitions, what is its name and the service, etc., some implementation details. Plus it also gives you information about what are the caches are stored within here as well. This then means that this is a snapshot that can be retrieved and is valid. So I can then remove the local snapshot. So I've got a local snapshot and I've archived it to a central location. Now if I say list snapshots, which is local snapshots, there's none there now. So if I then said delete from Tim, which is my cache, and then select count from Tim. Now what I want to do is retrieve the archive snapshot to the local members and then recover it. So I go say retrieve archive snapshot. Are we sure? Yes. So now that retrieves it from the central location and distributes to all the members. So in this case we've only got one machine, but if there was 10 machines, we'll distribute it evenly across all those members. Then if I said list snapshots, and then we can recover the snapshot. If we have a look, we can see select. Now we've got one record which includes that snapshot. So you can see how easy it is to create snapshots, archive them to central locations, validate them, and then retrieve them back. Up to now we've been utilising the CoQL commands interactively, but if you wanted to create a scheduled backup, then using something like, say, cron, you can then use the -f option of CoQL, which allows you to execute a set of commands from a file. So if I said cat test.coql, so it's a file, I'm then going to exit if there's any CoQL errors. I'm going to list snapshots, create a snapshot, validate, archive, and then remove. So to run this, we run our query, but use -f and run our test.coql. So you can see that's running. It's then listed the snapshots. It's creating a snapshot. It's now validating that snapshot. Showing the information. It's archiving the snapshot and then removing the archive snapshot. So it's very easy to script this. What I'd like to show you now is how we interact with Persistence when we're in a managed Coherence server environment, i.e. WebLogic server. So if we look at our WST script, we're basically connecting to the admin server, we're making sure we're in domain runtime, and we're issuing these commands. So we're going to list snapshot, create snapshot, list again, recover, and remove. Now when you run WST, these commands are automatically available, and any errors will raise a persistence exception. So if I run this, weblogic.wst, see we're connecting to the admin server. It's then creating the snapshots, listing the snapshots, recovering and removing. I hope you can see from the demonstration how powerful the functionality is and how easy it is to use. Thank you very much for your time today, and I hope you enjoyed the presentation.